The force that is Mother Nature has the power to create and equally the power to destroy. And the greatest weapon in her arsenal has to be water. Without this precious resource, life couldn't exist. But when Mother Nature wants to unleash the devastating power that water could bring, it is humanity that is left in the wake of her fury. On today's program, we examine the role of the Lake Simcoe Region Conservation Authority in developing an integrated stormwater management plan that has helped shape how and where we build our homes to avoid the terrible impacts of stormwater. We also look at the LSRCA's work in retrofitting stormwater management areas to make them holistically more beneficial. And we speak with developer Paul Bailey about his innovative plans for a new housing development in the town of Newmarket. That's today on A Greener York, brought to you by PowerStream. As stated by the Ministry of Natural Resources, flooding is considered the most significant natural hazard in Ontario in terms of death, damage, and civil disruption. In this past year alone, we saw the devastation that was caused by severe weather in various areas within southern Ontario. In April of 2013, both the towns of Huntsville and Bracebridge declared states of emergency when a combination of spring thaw and heavy rains caused flooding so severe, large areas of both towns were under several feet of water. In July of that same year, intense rainfall caused flash flooding in the city of Toronto, leaving certain areas under several feet of water. And locally, the town of East Gwillimbury declared a state of emergency when severe flooding occurred in the Holland Marsh after heavy rainfall, leaving 190 acres of farmland underwater, causing the destruction of $1 million worth of crops. The impact of the flood events really calls to attention the work that organizations such as the Lake Simcoe Region Conservation Authority are doing to mitigate the effects of stormwater runoff through management, restoration of the subwatershed, and regulation of housing development. Rob Baldwin, Director of Planning and Development for LSRCA.
The conservation authorities both were born out of both Hurricane Hazel, but also issues with tree clearing over the Oak Ridges Moraine in the 30s and the Dust Bowl that happened prior to World War II. So the intent of the authorities sort of evolved over about a 15-year period. Hurricane Hazel really cemented the importance of managing floodplains, and like the city of Toronto was the hardest hit probably within this whole area, but also local areas such as Lake Simcoe were affected. And really what it cemented is that building and having too much activity or homes or businesses in the floodplain is not really a good idea, because floods can happen, and the damage that was incurred and the loss of life was significant. So one of the core mandates of conservation authorities was to protect people and property from flood damage. Floodplain is the area in which a river, during an event, say the hurricane or a large rain event, the water rises in the river and it can spill, so basically, and dissipate, lose its energy, and then when the rain stops, the water will recede back into its sort of normal river. And floodplains vary in size depending on the size of the river. So small creeks, it's very, very narrow. Large rivers like the Holland River down and through Holland Landing, etc. I mean, it's a very wide floodplain. The floodplain is several kilometers wide.
Historically, development occurred in floodplains because people depended upon harnessing the energy of the nearby river to run their industries. Such is the case for the towns of Aurora and Newmarket.
Downtown Newmarket is an area that is still susceptible to flooding. It doesn't happen very frequently because it's a well-managed system, but under the large event or the right circumstance, yes, the possibility does exist.
Today, development is not allowed within a floodplain. And to determine just how far those areas extend, LSRCA has created detailed floodplain maps.
A good example is this area represents the town, part of the town of Aurora. And again, this is would have been from an aerial photograph from the 1970s, and it would have been mapping would have been done to delineate the amount of flooding that would occur under a Hurricane Hazel type of event.
Real detailed floodplain mapping really began in the 70s. That was sort of when the real push on floodplain management in Ontario began. And through the 80s, but really the 90s when it really hit home, and we started to see some of the increasing natural disasters with flooding worldwide. And the foundation of that is two components. One is the weather information, which we get from Environment Canada mostly. But the other side of it is how do rivers flow and respond?
In order to accurately answer that question, data has been gathered using monitoring stations operating throughout the watershed. A key function of this station in Holland Landing is to measure the amount of water flowing through the East Holland River. David Lemke is Manager of Environmental Science and Monitoring.
Whenever we have a station like this, we try to maximize and use as many different sensors as we can. So primary, again, it collects water level that we turn into water flow, but we do collect air temperature, we collect water temperature, and then a couple other parameters that we're looking at to see their applicability in gauging the water chemistry, which is conductivity, to look at how that can relate to the chloride or the road salt amount in the creek, as well as turbidity, which can tell us a lot about the nutrient movement through the creek. We have a network of about 15 of these, as well as a number of rain gauges throughout the watershed. So we're going to be monitoring all those various components to see the responses of the various ones. And once we start to see rain fall, we're going to look at how fast the response is in the rivers themselves. So that'll depend on the intensity of the rain. It could depend on the duration or the days of rain that preceded this rainfall event. Then we want to see, again, how is that river responding? Is it responding very quickly? Are the water levels increasing very high? We know basically the morphology of the channel. We know where some of the high water level marks are. So we're going to watch that water level as it gets higher and closer to those water level marks, and we'll start to look at when it might crest over them, or if it might crest over, or if we'll see that, that rise in water level start to taper off as the rain recedes. So just using all of these together, you can get a good picture of what's happening throughout the watershed.
And with that information, then you can put into a series of models that can predict the ultimate events or the large scale events. So we're able to say we have 15 storms of say 1 in 20 year type frequency. We're able to then extrapolate that information to say if we have the 1 in 100 or the Hurricane Hazel type event, that regional event will be able to predict that much rain, this is how the river responds, here's how wider or bigger the floodplain will become, and how either deep or how fast the water may move. So we're able to really define those floodplains.
These maps cover every community within the sub-watershed and can determine which areas will flood under particular storm conditions. This information is shared with the municipalities and emergency service agencies, as well as the public. The maps are easily accessible on the LSRCA website. The data collected at the stations is also used in real time to determine if there's a potential threat of flooding, and if that is the case, the LSRCA is responsible for issuing flood warnings. Tom Hogenberg is Manager of Engineering and Technical Services. A key role for his department is the management of the flood forecasting system.
Well, it's a daily process, and what we call it the daily planning cycle. So initially we get weather forecasts from Environment Canada. We access sites that have these forecasts. We access American sites that deal with information of what's coming up from the US. We also get information from the Ministry of Natural Resources. We also get information from other conservation authorities. We put this all together, and it's a bit of a decision process by which what are we expecting for that particular day. At that point in the morning, it's usually first thing that we come in. The decision is made whether to go to any kind of flood bulletin or not. Now, having said that, then we also monitor conditions throughout the day, and if there's a sudden change in weather conditions, it may trigger the need to issue a flood bulletin as well.
The number of flood bulletins has increased over the years. One particular event that may contribute to the risk of potential flood is the increase in winter melts.
It was very common that you would have a March large melt event. All your snowpack would go down and melt off into the creeks, and you have a large flow through that period. Now, especially these last few years, we can think of January melts, February melts, and we're typically getting 2 to 3 to 4 of these large melt events in a winter season. And that we're really seeing can have an impact on the river flow. So again, just like when you pave over a surface, if that surface is frozen, a lot of that water that may come as rainfall or snow melt goes right to the rivers. So we get high water levels in the rivers for what could be a small amount of rain or melt. Coupled with that, we might have ice jamming. So the risk of flooding through these winter melt events can be rather severe.
So what we're seeing in the summer now are these intense and dense storms, basically very short duration storms that dump a large amount of water in a short period of time, but usually in very localized areas. It may not be the entire Lake Simcoe watershed. It could be Barrie, could be Newmarket, and we've seen that specifically over the last 5 years.
As storms become more intense, the need to strengthen and protect the sub-watershed becomes increasingly important if we want to have any chance in negating the detrimental impacts of climate change on the environment. Coming up after the break, we explore the role that floodplains play in strengthening and sustaining the watershed and visit Holland Landing to see a stormwater restoration. Stay tuned, we'll be right back. Floodplains contain some of the most critical wetlands in the watershed, as well as the riparian forests that not only serve as habitat for wildlife, but also act as buffer zones for pollutants entering the river system. The Lake Simcoe Region Conservation Authority is working to revitalize areas along the entire sub-watershed to recreate a stronger ecosystem that in turn will improve the overall health of Lake Simcoe.
In the last 10-15 years, we've seen a real big evolution about protection and the value of wetlands. When they looked at the sort of recurring flooding of the Mississippi River in the United States, the main cause wasn't heavy rains, it was that the wetlands were all gone, or the majority of wetlands were all gone. So that ability to store and slow down water and retain it instead of it just running off, that's gone. So the province and then through the conservation authorities has recognized wetlands are absolutely critical, not only to help in flood retention and reducing flood risk, but they are also probably the most critical thing in improving water quality into Lake Simcoe.
The more resiliency you can build into the system, that resiliency is really going to come in allowing that river system to behave in a more natural way. Rivers are very dynamic as they are. They handle flows that can vary greatly year by year. They know how to handle a spring freshet. But if we hit them with spring freshets, 3 times a year, obviously that starts to have these impacts. So the real idea here is building resiliency, is allowing the systems to behave more naturally. So again, going back to this idea of water-sensitive urban design, how do we look to interacting with the natural landscape and having our impacts and our activities mimic more closely the natural system and mimic more closely the natural water cycle.
Through our stewardship program, we have a landowner environmental assistance program, and we deal with different projects that look at improvements to water quality. I deal with quite a few different projects dealing with stream bank stabilization, trying to naturalize them using bioengineering techniques, and other areas where we deal with stormwater management improvements to improve the quality of the water before it discharges into the adjacent streams and rivers. Right now we're in Holland Landing, and this is in the town of East Gwillimbury. This is a project we did just 2 years ago with various partners. This is a town of East Gwillimbury property, and prior to this work being done, there was just under 12 hectares of stormwater coming from a residential subdivision draining straight into the river behind us. Working with all the partners and permit agencies, we came up with a hybrid system that basically will improve the water quality and create some storage. The idea is that the water now goes through a sediment forebay with some wetland cell components, and slowing that water down gives the opportunity for the fines to settle, and then after the soluble water can then go through some of the vegetation in front of me that then picks up some of that soluble phosphorus as well. So the end result is when it leaves this treatment facility, it becomes that much cleaner before going into the river system. So one of the big things we always look at is bang for your buck. What kind of improvement are we going to have here? So a lot of pre-construction monitoring is important here. So a lot of our staff, our monitoring crew will come out here, take some samples of the water before this system is built. And based on the area, the drainage area for this area, it is approximately 12 kilogram of phosphorus reduction per year that this system now can do. Based on some of the post-construction samples we've taken, it is actually doing that. So it's working quite well, and as soon as the area became mature and established, that really is where it kicked in and started to do what it's supposed to do.
And like many of the projects happening in the sub-watershed, public participation is a key factor to the success of the project.
Any project that we have, we always try to find a way, an opportunity to try to educate the public. In this particular site, we were lucky because of the fact that there's a trail system right adjacent to it. So signage is a key. There's a signage just behind me here that explains to the public and landowners why we did this, what's the benefits. The other thing is we try to get the community involved. So a lot of these projects, there's a large planting component. So after the construction was done and basically the final grading was done, over 1,000 potted trees and shrubs were planted by the community. And actually this one was done on Mother's Day. And again, if you look around, you can see the success of the plants. They've done very well. So just getting that public involved, they really seem to bond to the site and have some sort of attachment when they're actually putting plants in the project itself.
Any project in the sub-watershed is subject to review and permitting before it can be approved, and that extends to private properties within those regulated areas. Bev Booth is Manager of Planning, Regulations, and Enforcement.
The permit process is under Section 28 of the Conservation Authorities Act, and it's a tool used by conservation authorities to protect landowners against natural hazards. And natural hazards are naturally occurring features such as erosion and flooding. It's only particular areas, and it's focused on the shoreline of Lake Simcoe, on watercourses that drain into Lake Simcoe, and wetland areas that are associated with those watercourses as well. And the Conservation Authority in 2006 undertook a very ambitious mapping project to as accurately as possible, map the areas where permits are required from the Conservation Authority.
Okay, saying that the cedar
LSRCA requires residents to submit a detailed application that includes plans of the proposed work. Once the application has been accepted, a site inspection is conducted, and based on that inspection, a technical review will be conducted to determine whether the application is in accordance with LSRCA policy and whether a permit can be granted.
So what I would suggest, rather than putting a shore wall, like a vertical shore wall, considering putting granite boulders.
Very rarely have to say no to an applicant. We always try to work with them and give them the benefit of our experience in terms of how their application might be modified, something that we could approve.
And to that end, you know, we can accommodate a permit application for that.
So the whole focus of our program is to protect people's lives, protect their investment, and to make sure that other people's lives and property are not affected, and also to ensure that the natural environment is also either enhanced or protected.
When it comes to large-scale development, there are numerous regulations pertaining to the management of stormwater to ensure there is a minimal impact to the environment. Coming up after the break, we visit the site of Mosaic Homes' latest development project to learn about new stormwater management technologies. Stay tuned, we'll be right back. There are standard requirements when it comes to controlling stormwater. How much can be released back into the watershed, how much phosphorus it can contain, and what the overall impact is going to be on the downstream environment. Developer Paul Bailey and his partners at Mosaic Homes are aiming to surpass these building standards to ensure that their latest housing project stands out as a beacon of water conservation and stormwater control. Located on Davis Drive just south of Bathurst is the 30-acre property. Currently, it is buried under several feet of snow, but once construction begins, this former farm is going to be transformed into a 185-lot community featuring stormwater designs that up until this point have not been used in a development of this nature.
The amount of water that comes off the site when it's a farm is far different from the amount of water and the speed with which it comes off the site when it's a fully developed subdivision with 185 houses. So we need to account for that change in intensity of flow after development and the quality of water and the amount of water. Lake Simcoe Region Conservation Authority has a very large role in approving all of our designs for stormwater management and treatment. And they played a very helpful role for this particular project in considering new technologies, new approaches, and even pioneering some kinds of designs that probably haven't popped up in subdivisions in Ontario. We are going to deal with water conservation and good water practices both on the site itself and internal to the houses. So on the site itself, we have a new system, new techniques called low impact development technologies. And we are using some of those technologies. We're using a system of bioretention swales. We've got a very large one on the west side of the property, taking drainage from west of Bathurst, from even off our site. And we're also taking internal drainage and directing that into a separate and second bioswale. The bioswales will negate the need for a typical stormwater management pond, so there'll be no storm pond. Instead, the bioswales will clean the water that goes into them from the roads, and will also generate less runoff by assisting in absorbing water and returning it back into the ground, staying on the site. We have a number of other features too. Rain gardens are going to be employed on all of the corner lots, and the idea of the rain garden is it will take flow, overland flow, from the lot itself and return it back into the ground by retaining it in the rain garden, giving it time to percolate back into the soil. We also have a very unusual stormwater pipe system where we use what are called exfiltration pipes. Exfiltration is where storm flows are directed into a storm pipe in the road, and basically and simplistically the pipe has holes in it. So the storm water in the pipe, instead of running through the pipe and off the site, can actually percolate back into the ground as it spends time by delaying the flows in the pipe. We also have an underground storage tank which will store stormwater flows in the event of a very significant rainfall.
Every home will have water conservation technologies, including 3.8-liter toilets, hot water recirculation systems, drain water heat recovery, low-flow shower heads and faucets, water-saving furnace humidifiers, and front-load washing machines. Combined, estimated water conservation will be 25% greater than what is Ontario's current building code standard.
I think the whole menu of treatments and approaches we have to stormwater for the site likely is going to be the most innovative and most novel to date in York Region. I think our industry, and this for me personally, needs to try a little bit harder on the environmental front. We are a heavily legislated, heavily regulated industry, and as a result I think people generally have been left with just doing what you have to. These environmental things that we're talking about here today are over and above what we have to do. They're above the building code, they're above the Energy Star requirements. They're things that we don't have to do, but I think they'll result in better communities. I'd like to think that we can do better in making better communities, and it's going to be a worthwhile effort.
Once the subdivision is completed, The LSRCA will be monitoring the stormwater system to see how well the system performs and if it can in fact exceed the standard requirements in place for stormwater quantity and quality returning to the subwatershed. Lake Simcoe Region Conservation Authority is constantly striving to improve the way in which its staff approach stormwater management by innovating and implementing the most effective methods based on scientific observation, all to not only protect Lake Simcoe and its watershed, but to also improve the communities that reside within it. To learn more about LSRCA stormwater management and flood forecasting, please visit us online for details. For A Greener York, brought to you by PowerStream, I want to thank you for watching. And remember, together we can make our community a greener place to live.